Alright guys, so let's go and try and do a couple of these problems together. So let's see if we can get through some of this stuff. So go to our highlighter and let's read our first question. So an advertising representative meets two clients on the same day in her schedule. She determines to meet the first client every 14 days. So she's going to meet one client every 14 days and the second client every 30 days. How many days will it take before she meets the two clients on the same day again? So we're looking for how many times, so what's the least common amount of times, or the least common multiple, or the least common amount of days will it take before she meets the two clients again. So what we need to do is we need to do our prime factorization. We need to decompose the numbers. And in this case we have 14 days and 30 days. So if we take 14 and 30 and we break them up, well, let's go ahead and try and break these ones down. So if we take 14, it's made up of 2 times 7 gives us 14, and 30 can be made up of 10 and 3, but 10 is not a prime number. We can break that down even more if we go 2 times 5. So what do these two numbers have in common? Well, they have the 2, and that's pretty much it. They don't have anything else in common. So the greatest common divisor of 14 and 30 is 2. But what are the other factors that make up 14 and 30? Well, 14 is made up of 7, and 30 is made up of 5 and 3. Now, we found the greatest common divisor, but we don't need that right now. What we're looking for is the least common multiple of 14 and 30. So how do we find that out? Well, we multiply our prime factors. So if we go 7 times 2 times 5 times 3, we get 210 as our least common multiple. So how many days will it take before she meets the two clients on the same day? Okay, it will take 210 days. Now that's if we're looking for the least common multiple for two numbers. And a Venn diagram works when we're comparing two different things. But what happens if we're doing it for three numbers? So our question is here, so we'll get out our highlighter to highlight the important information. So 3 speed skaters train on a circular track. Annie completes one lap in 27 seconds, Beatrice in 30 seconds, and Cynthia in 36 seconds. If all 3 skaters leave the start line at the same time, how many laps will each complete before all 3 meet again at the start line at the same time? So we're looking for the least common multiple of 3 numbers. And the Venn diagram doesn't work. But let's go and start off the way we know how, which is we need to break down the numbers. So if we take Annie, who's gone 27 seconds around the track, Beatrice, who's gone 30 seconds around the track, and Cynthia, who's gone 36 seconds, what are the prime factors that make up these numbers? Well, if we take Annie's time, 27 is 3 times 9, and 9 can be broken down into 3 times 3. So we've got our prime factors for Annie. Now what about Beatrice? Well, 30 can be broken down into 10 and 3, and 10 can be broken down into 2 and 5. So 2 times 5 is 10, 10 times 3 is 30, so we know we're good. Okay, and then Cynthia, who's at 36 seconds, can be broken down into 3 and 12, and 12 can be broken down into 2 and 6, and then 6 can be broken down into 2 and 3. So now we've got our prime factors, but we need to come up with how to sort of figure out what our least common multiple is, because not all these numbers are going to have the same numbers in common. So we need to sort of figure out how that's going to work. So here's what we're going to do. So what numbers do we know that they have in common? All 3 of them. Well, Annie, Beatrice, and Cynthia all have the number 3 in common. Okay, so that is one common multiple. So we'll bring the 3 down here. Once we've brought it down here, cross it out so we don't use it again by accident. Okay, so that's one common multiple. Now, let's see, are there other common multiples between them? So Annie's got a number 3. But Beatrice doesn't have a 3 anymore, so we need to go and see if maybe Cynthia does. Oh, okay, look, we got Cynthia. Cynthia has a 3. So both Annie and Cynthia have a common multiple of 3. So we'll use that one now. And once we've brought it down, cross it off. Now, Annie's got another 3, but nobody else does. So we'll save this one for after. Let's see if there's other common multiples. Well, Beatrice has a 2, and so does Cynthia. So another common multiple is 2. So we'll multiply by 2. So we got 3 times 3 times 2. Now what numbers do we have left? Well, we have 3, 5, and 2. Those are not common multiples, those are just our regular prime factors. So we add these down at the end. So we bring down the 3, bring down the 5, and bring down the 2. So we have 3 times 3 times 2 times 3 times 5 times 2, which gives us 540. Or we could rewrite it if we want as 1, well, here we have how many 3's? 1, 2, 3 3, so 3 to the power of 3 times 2 to the power of 2 times 5. So if you do that, 3 to the power of 3 times 2 to the power of 2 times 5, it'll give us also 540. So these are the same thing. So now we have what our least common multiple for all these speed skaters. It's 540. But now we have another problem. We have to figure out how many laps will each of these people complete before all 3 meet again at the start line. So how do we do that? Well, we have our least common multiple, and we have how fast each one is skating. Now what we have to do is use our least common multiple and divide. So if we go and take Annie up here, and we go, alright, well, Annie was able to do skate, what's it called, 540 laps. Okay, 540. She was going 540 seconds. That's why it's important to keep units. So Annie would take 540 seconds, but she was skating. It took her 27 seconds to do 1 lap. So if I go 540 divided by 27, that'll give me, it'll take her 27 laps. Okay, 27 laps to meet Beatrice and Cynthia. And if I took Cynthia and divided 540 by 30, the other way around, my mistake, guys, and divided 540 by 30, okay, so 540 divided by 30, that would end up giving me 18. So it would take Beatrice 18 laps. Not labs. We're not dealing with dogs, it would take laps. Okay, 18 laps. And if we take Cynthia, who was skating, took her 36 seconds to do 1 lap. So if we go 540 divided by 36, it's going to take Cynthia 15 laps. So the amount of time it's going to take for them to meet at the starting line, it's going to take Annie 20 laps, and then Beatrice 18 laps, and Cynthia 15 laps. That's how many laps. So that's answering our question. How many laps will each complete before all 3 meet again? Well, Annie will complete 20, Beatrice will complete 18, and Cynthia will complete 15. That's how we find our least common multiple for when we have more than 3 numbers. Now we can still do one last problem, which is a new hospital is being opened, and we have 24 doctors, 56 nurses, and 88 nursing assistants that are being hired. Okay, so we get our highlighter out, and we have our 24 doctors, 56 nurses, and 88 nursing assistants are hired. The director wants to form medical teams of the same composition. How many medical teams will there be, and what will be the composition of the medical teams? Well, to do that, we need to find our greatest common divisor. So, we'll do what we've done before. We take our 24 doctors, our 56 nurses, and our 88 nursing assistants and we break down these numbers. Well, 24, so the number 24 can be divided into 4 and 6. 4 times 6 gives me 24. And then 2 and 3, 2 times 3 give me 6, and 2 times 2 give me 4. So we've broken down this number. Now if we take 56, well, what two numbers give us, 56? Okay, well, if we go and take 8 and 7, 8 times 7 gives us 56. 7 is a prime number. Break down that 8 into 4 and 2, and break down that 4 into 2 and 2, we have our prime factors here. Now if we do 88, well, 8 times 11 is 88, and 11 is a prime factor, so we keep going down. We've already broken down 8 before, so we know it's going to be 4 and 2 to make 8, and then 2 times 2 to make 4. So we have all our prime factors. Now what is the greatest common divisor for each one? Well, the number 24 has 1, 2, 3 2's. And the number 56 also has 1, 2, 3 2's. And the number 88 also has 1, 2, 3 2's. So our greatest common divisor of 24, 56, and 88 is 2 to the power of 3, or 8. So how many medical teams will there be? Well, our answer to A is that there will be 8 medical teams. Okay, so we know that there will be, our answer to A is that there will be 8. Wow. Our answer to A is that there are 8 medical teams. Now, what if we want to go and answer the next question? So answer question B, which asks us, what will the composition be of each team? Well, we need to make sure that each team, since we have 8 teams, we need to make sure we get doctors and nurses and nursing assistants for each one. And we need to use our greatest common divisor to figure out what that'll be. So if we take 24 and divide it by 8, we get 3. Okay, so we know we'll have 3 doctors. Okay, so now if we take our 56 nurses and divide it by 8, we know we'll have 7 nurses per medical team. And if we take our 88 nursing assistants and divide them by 8, we'll get 11. We'll get 11 nursing assistants. So this is our answer to B. So what will be the composition of each team? Well, each team will have 3 doctors, 7 nurses, and 11 nursing assistants. All we need to do to find the greatest common divisor is find out what numbers, what prime factors each one has in common. That's it to find the greatest common divisor. If we're looking for the least common multiple for 3 numbers, we need to sort of find out, first off, what each number we've broken down has in common, then find out what number each has in common with the other, and then until we've got left with nothing but prime factors that aren't common factors. So the way we did that, you guys had seen. And for 2 numbers, it's straightforward. You can use your Venn diagram, and that's it to find the least common multiple. So I hope this video was helpful and helps you guys figure out your homework. And that's really it. So take care and have a good day, guys. I'll see you in class on Monday. Bye bye.